Okay, so we're going to look at factoring a polynomial. So to factor a polynomial, identify the common factors and simply divide the common factor of the coefficients. Using the quotient rules for exponents, identify the smallest exponent for the variables. This will be the exponent for the common factor for those variables. Okay, so lots of wording on that one. So if I am given this polynomial here, so I have 3 times v cubed times y to the 4th power minus 48 times v cubed. So for this one, when I go to factor this out, I want to look at the biggest thing I can factor out of everything. So 3 and 48 can both divide by 3, and then they both share a v cubed. So that means I can take out v cubed from both. So remember, that's why I said the smallest exponent. I know that sounds kind of funny, but if I only had like a squared here and a cubed here, well, I could only take a squared away from both because that's all that this one would have to give. Since they both have a v cubed, I can take v cubed out of both. But I can't take any y's because this 48 v cubed doesn't have any y's to give. So just kind of be, aware of that part. So when I divide 3 by 3, I get 1. V cubed divided by v cubed, I get 1 again. So the only thing I'm left with here is the y to the 4th power. And then 48 divided by 3 is 16. V cubed divided by v cubed is 1. So I'm left with just the 16. So this was factoring out the greatest common factor. Now we're going to write y to the 4th minus 16 as difference of squares because I have a square minus a square. So I can factor this again. So I have 3v cubed. And with this one, the main thing is I want to make sure that I'm paying attention to what's being squared here. That's why I'm rewriting it this way. So I have y squared squared, because that's how I got y to the 4th. I'm actually squaring y squared minus 4 squared, because 16 is 4 squared. So I'm just kind of showing you how it's, we do that when it's not a square here, it's to the 4th power, but I'm still squaring it. So here it is. You can see it written as y squared minus 4, y squared plus 4. So that's a difference of squares. We actually have a difference of squares again because y squared minus 4, here's a square minus a square. So we can do this again. So I have the 3v cubed in the front still. But now I can write y minus 2 and y plus 2. I can separate this one in the middle out because it's another difference of squares. The y squared plus 4, that can't be used in that same format because that's not a difference of squares. That is not a pattern that we can factor. So this is completely factored all the way. So definitely that difference of squares is a big one to help memorize, to go through this one, because it makes it so much easier if you recognize it right away. Oh, that's 2 squares being subtracted from each other and I can subtract. So be aware also they're going to start to throw these types of questions at you where you have more, it's not just a square, it's a square squared. Okay, so we're going to try one more of these, so factor completely. So we have v cubed times x to the 4th minus 81 v cubed. So common factors of coefficients, well, this one has a 1 and an 81. So really only 1 is the common factor of the coefficients because there's, 1. And 81 can, of course, divide by 1, but it doesn't change anything. Common factor of the variable v, well, I have 3 here and I have 3 here, so it's going to be, v cubed. So yes, I do have a common factor there. And then common factor of x, well, no, I don't have one because there's only 1 here. There isn't one on this second one. So I have nothing to take as far as x's go from 81 v cubed because there are no x's. So, and is there a difference of squares? Once I have factored out the only common factor I have, which was v cubed, that was the only piece that I had there. So the v cubed really just kind of cancels itself out. It comes out to the front here. So I have x to the 4th minus 81. Well, now I do have a square minus a square. So yes, I can factor this. So remember, x to the 4th means x squared squared. And then 81 was 9 squared. So again, just separating that out so that I can now rewrite it as x squared minus 9, x squared plus 9. And it's the same pattern that we saw in the last one. Now I still have a square minus a square in this middle term here. So I'm going to have to factor that out again. So you can see I added this one and x squared minus 9, that's another one. So I can do x minus 3 and x plus 3 just for the middle one here, the x squared minus 9. The x squared plus 9 is not a difference of squares, because remember, difference means subtract. So this one is not fitting within that pattern. All right, so I hope that helped with factoring or completely factoring polynomials here using difference of squares more than once. I will see you on the next video.